In this video, we are going to be doing an introductory to factorization. We will be looking at some of the different forms of equations and expressions that could be factorized. Firstly, we need to know what is factorization. It is defined as a process of breaking down a number or an expression into a product of different numbers or expressions called factors. In other words, it is a way of simplifying a number or expression in parts to better understand it or extract specific data. Looking at the example, it is shown how the expression is separated by factorizing. The brackets are used to represent the function of a product. In other words, to multiply the given data inside the brackets by what is outside the brackets. So if we multiply 3 by the x, we get 3x, and multiplying the 3 by 1 gives us 3. So there we formulated the original expression.
Given 4x plus 8, we firstly look at what is common between the two individual numbers or coefficients corresponding to an unknown. We then introduce the brackets to separate the factors from the common value. The factors are then placed inside of the brackets.
If we have 7y plus 35, we can see that 7 is the only common value since 7 is also divisible by 35. In the brackets, y will be written first because it is the first factor of the 7y in the given expression, and 5 will be the final factor since the product of 7 and y gives 35. Using this same concept, we can factorize an expression without any known values. Look for what's common between y squared and y, which will be y. In the brackets, we have y firstly, then 1, because y multiplied by 1 will give the original y from the expression. Looking at the other example, there is only the number 15 in common. 15 multiplied by what will give 30x. That's why we introduce firstly the 2x in the brackets followed by the y. Looking at more complicated expressions, as long as the common number or expression is pulled out between the content of the expression, then the factors can be obtained in the brackets easily. If we must not be baffled by the varying differences in numbers and unknowns. Looking at what is common, we have 7 because it is a factor of 21, and 49x is also common as it exists in each content of the expression. Hence, 7x outside the brackets and the factors inside.
Difference of two squares is a square number subtracted from another square number. To better understand the difference of two squares, we have the factorized form of it. Expanding the expression we get and simplifying the expression is the difference of two squares. Given the expression x squared minus 49, we can see that another square term can be introduced in place of the number. Then we consider the first value a and the second b using the factorized form given in red to factorize the difference of two squares expression to get. From the factorized expression, we can see that the difference of two squares can also be defined as the product of the sum and difference of two numbers.
Looking at another example, we can see that 16y squared is a perfect square. In order to factorize, we need to introduce the second squared term, which will be 4y to be squared. Then, using the factorized form, we get x plus 4y multiplied by x minus 4y. The key is to get the two squared terms. Then consider the first term a and the second term b, and we use the factorized form given to completely factorize the expression.
If we are given an expression in the form x squared plus 2xy plus y squared, it could be factorized by using the factorized form of the equation x plus y multiplied by x plus y, which is also the same as x plus y squared. For proof of this, we will expand and simplify the factorized form. Multiplying by the FOIL method, we expand to get x squared plus xy plus xy plus y squared, and since the xy terms are the same, we add the coefficients to get x squared plus 2xy plus y squared. Let's look at some examples. Given a squared plus 8a plus 16, we then compare the general form of the trinomial. Using this form, we can expand the trinomial. Notice that a corresponds with x and 4 corresponds with y. We can then completely factorize the trinomial to get a plus 4 multiplied by a plus 4.
Given these trinomials, we firstly expand to the general form. Notice that the common unknowns highlighted in yellow and red must be the same value. So factors in the middle term, when multiplied, must give the same value in the original expression, and when compared to the terms in the extreme left and right of the trinomial must be the same. Now, we can completely factorize the trinomials by combining the individual terms to get 5x plus y multiplied by 5x plus y and 2p plus 3r multiplied by 2p plus 3r. If we are given an expression x squared plus 7x plus 6, in order to factorize, we will firstly need to identify each individual term. Comparing it to the form of the trinomial, we can see that a is equal to 1 by taking the coefficient in front of x, b is equal to 7, and the constant c is equal to 6.
Now that we have identified the parts of this trinomial, we will begin to factorize it. Firstly, we need to separate b into two terms to be grouped and factorized. To do this, we find the product of a and c. Then, we list all the possible multiples which would give the value of 6. Looking at these multiples, we choose the one when multiplied gives back the value of AC, and when added gives the value of B. Therefore, we take the factors 1 and 6, because 1 multiplied by 6 equals 6 and 1 plus 6 equals 7. Now we can expand the trinomial by replacing B term with the two new acquired terms. Since B is a coefficient also representing an unknown x, we must include the x with the two new terms. And since the coefficient 1 is understood, we do not have to include it. From this stage, we look at the first two terms of the expanded expression, pull out what's common, introduce the brackets, and put the factors inside the brackets. We introduce another pair of brackets that must be the same as the first. By looking at the second set of terms inside the expression, we can determine the value that goes outside of the brackets, which would be 6. From this stage, we simply group the terms outside the brackets with the ones inside the brackets. Now the expression is completely factorized. Let's look at more examples. We are given the trinomial x squared minus 9x plus 20. We will have a equals 1, b equals negative 9, and c equals 20. AC will be 1 multiplied by 20 to give 20. Listing the multiples of 20, we have 2 by 10 and 4 by 5. From these multiples, we will need to choose the one to sum to negative 9. Since positive 4 plus positive 5 is equal to 9, we can simply manipulate the signs to get negative 9. Hence, we have negative 4 plus negative 5 equals to negative 9. And the product of negative 4 and negative 5 equals 20. Now, we expand our trinomials to get x squared minus 4x minus 5x plus 20. From here, we can easily pull out what is common and introduce the brackets. Then the group of terms together.
If we are given a trinomial 8x squared plus 18x plus 4, a in this case would be 8, b equal 18, and c equals 4. We then continue as normal and find AC. By listing the other multiples of 32, we have 1 by 32 and 2 by 16. Since 2 plus 16 gives 18, we will use that multiple as the middle terms in the trinomial. Now we can pull out what is common and introduce the brackets, then group the terms together.
Stand up like a soldier, baby. Yeah, I know you built like that. Gun it like a holster, baby. Show them say you're wicked like that.